Okay, hello students. If you are getting ready for algebra, then you've come to the right spot. I am presenting a 1 to 2 week preview of algebra so you can dive in, ready to go, hit the ground running. And I have a link in the description to these notes right here so you can print them out, follow along as I go through all of my lessons. And let's get started. I'm going to remove this here and let's talk about, well, as you're getting into algebra, what is algebra? Well, my idea of algebra is the generalization of arithmetic by using letters for numbers. And this arithmetic, that's when you add, subtract, multiply, and divide numbers. And before we had something like I don't know, um, 4 plus 3, right? But now we're going to have something like 4x plus 3x, or 7y plus 7y, yeah, plus 6, something like this. And we're going to be manipulating these things in all kinds of weird ways. Okay, I'm going to erase that little part and move on to the next. The main components of algebra. Well, we have one main component is evaluating expressions, and I have a little practice problem. And by the way, I'm going to usually have practice problems throughout this. You'll have exercises, and I'll have solutions to those exercises. So, evaluating expressions like this one, if you evaluate this 3x minus 4 for x equals 2. So this right here is known as an expression. And later we're going to talk about equations. So expressions and equations, they're different beasts, but they look very similar. So we evaluate this, and the way we do that is we take this 2 and we substitute it for x. So this then would be 3, and that 3x means 3 times x, right? So that's 3 times x minus 4, and x is, in this case, 2. So we have 3 times 2, and I'm going to put the 2 in parentheses here, and that also means 3 times 2. Because if I didn't put the parentheses there, if I have just 3, 2, that looks like it's 32. So to avoid that, we'll have 3 times 2, and then minus 4. And now, when we evaluate these expressions, we have to follow the order of operations. That is parentheses, exponents, multiply or divide, and then add or add or subtract. And when I say multiply or divide, I mean from left to right. And when I say add or subtract, I mean that from left to right. And I'll have specific exercises and lessons all about evaluating expressions. This is just an overview right now. But when we evaluate this, we start with any parentheses. We do have parentheses here, but there's nothing to do in the parentheses. So that part's done. The exponents, I haven't talked about exponents yet. We would multiply or divide. Well, I see multiplication right here, so I'll do that part. And that would be 3 times 2, which is 6. And then I'll write down the rest of what I didn't do, 6 minus 4. And now it looks like I've completed this whole level here, and I'll go down to add or subtract. I see subtraction. 6 minus 4 is 2. So actually, x equals 2, and the answer ended up being 2. So that's kind of I didn't anticipate that. It happened to be a coincidence. Okay, so let's move on to the next part. Solving equations. And in this, we also find zeros, and that has to do with the graphing part. But we start with just solving equations. And a very simple one that I got is solve 3x equals 12. And like I've shown before, that 3x means that's 3 times x. So 3 times something is 12, and obviously that's 4, right? 3 times 4 is 12. But what we often use is we use this idea of inverse operations, and add and is the opposite of subtract. So these are inverse operations. Add and subtract, they are inverse operations, which means they cancel each other out. We have a multiply is the inverse of divide. And so, like I said, we already know that x equals 4, right? Because 3 times 4 is 12. But to do more complicated equation solving, we would use this idea of inverse operations, and we would use division. So if that's multiplication, we would divide by 3 on both sides of the equal sign. And this, so 3 times x divided by 3, well, they cancel out. And x is now equal to whatever 12 divided by 3 is, which is 4. So that's another way of showing that part. And again, this is just really a preview. We're going to go into much more depth. So x is equal to 4. I'll bring it a little bit closer right there. We'll go into much more depth in a later lesson. Another big thing that we do is we graph equations, and we graph like linear equations like y equals 3x. And we graph them on these graphs like this. And this is called like a xy coordinate plane, where the x-axis is the horizontal and the y-axis is the vertical. And if we graph this equation here, we will, well, like, okay, there's a little bit more to know too. There is the variables now. The variable here, this is the independent. Wow, I did a terrible job of writing that out. Let me do a better job of that. So, and the y is called the dependent. So the independent variables, you can choose anything you want for that. And the dependent variables, they depend on what happened when you put in the independent variables. So I'm going to say x is whatever it is, and y is going to be equal to 3x. So x, I can choose anything I want. Like it can be 2, and y would have to be 3 times x, which in this case is 2. So that'd be 6. X could be 0, and y would be 3 times 0, which is 0. And we could even have negative numbers, like x could be -1, and so y would be 3 times that x value, -1, which is -3. And so then we would graph these, and I should have had a third right here. That would be pretty helpful, where we have x and y. So we'll put it together. X is 2 and y is 6. X is 0 and y is 0, right? Because I'm getting it right from here. 2, 6 right here, 0, 0 right here. And then I'll get the last one, -1, comma 3. And now the magic happens is when we graph these. So I'm going to try to keep these here like this. And I'm going to graph the first one, 2, 6. 2, 6 would be 2 on the x, 6 on the y. It's this point right here. 0, 0 is the next point, and that's right in the middle. It's called the origin. And then the last one here is -1, 3. And -1, 3 means I go -1 on the x, and I believe -3, right? All of a sudden I realize, yep, that should have been -3 right there. -3, so that needs to be a -3. Let's zoom in on that one right there. So Let's erase and call that -3. Okay, so -1, -3, graphing that point would be -1, -3 would be right here. And so something strange kind of happens here where we see these dots, and hopefully you see that they make this line. And I'm going to try to do this line. I'm going to make it in blue, and I'm going to put my ruler up and try to connect these dots. And so that there it is. There's that linear line right there. So that we call this a linear equation because these dots form a straight line. And there's so much to unpack on that, but I'll just leave it at that point. This will be later. This is an overview of things, but these are the basics. And then we have finally one more, a nonlinear equation, and I have an example here of y equals x squared. And these nonlinears, you will study quadratic and cubic. This one is a quadratic. I know this is quadratic because that little 2 right there, that'll make a U-shaped curve, and those U-shaped curves are called parabolas. So quadratic equations make parabolas. And yeah, you know what? That would be a good thing to add in here. These make oops, they make parabolas, and the cubic, they make an S-shaped curve. So we will uncover this. So once again, we have the dependent and the independent, and the dependent, I'm sorry, the independent and the dependent. So x is the independent. I can choose anything I want for x. So I'll just choose I'll choose 2. So if x is 2, then y is equal to x squared. And so here comes our first exponent. And so what that means is that's going to be 2 for the x and a 2 for the exponent. That means 2 times 2, which is 4. I can choose 1 for x, and that would be 1 to the second. And that's 1 times 1, which is 1. I can choose 0. 0 to the second is 0 times 0, which is 0. And I can choose negative numbers too. I can choose -1. So this would be -1. I'm going to put this in parentheses because I want that 2 to apply to everything. So that means -1 times -1, which is +1, because a negative times a negative is a positive. And then we have -2, and that would be -2 squared, which means -2 times -2, which is +4. And then now we would have our x and y's right here. So that means we would have 2, 4, and we would have 1, 1, and 0, 0, and -1, 1, and -2, 4. And we can graph these on this xy plane. So we have 2, 4, so that means we go 2 on the x and 4 on the y. That's the first one right there. And then 1, 1, 1, 1 would be right there. 0, 0, excuse me, 0, 0. And then right here, I'm looking at -1, +1. That's -1 on the x, +1 on the y. Right there. And then -2, +4, -2, +4. And you might notice a little bit of symmetry going on here, where there's this on the, oops, I wanted to use green. On the y-axis here, it's like it's a mirror. And that's exactly what should be going on. That's called the axis of symmetry. Right here, axis of, you know what, that's not going to work out very good at all, is it? How about I do this, and I'll make this black right here. So that green line is the axis of symmetry. And so you're going to find the axis of symmetry and all that kind of stuff much later on in algebra. Again, just a preview here. And what we should see here is we should see this U-shaped curve. That U-shaped curve is called a parabola, as I mentioned earlier, and it goes on forever in both directions. So I'll put those arrows right there, and there you go. So this is the overview here, and in the coming series I will be presenting new lessons, and I'll have a whole separate page for you to download the notes and try some problems on your own. So I'm looking forward to this and working with you, and thanks for watching.